In this video, we're going to prove the Archimedean property. It says that if a and b are any integers, then there exists an integer n such that na will be bigger than or equal to b. You can multiply a, given any a and b, you can multiply a by some positive integer to get more than b. And this seems reasonable. You know, the integers are a equals 3 and b equals 7. Of course, I can multiply 3 by some number to get more than 7. I can multiply by 6. I can multiply by 3. Now, we're going to prove this by contradiction. Proof. Suppose otherwise. Well, what does that mean? That is, n times a is always less than b for any a, no matter what, for any n. No matter which n we pick, forget about it. It doesn't work. For every positive, and it's still positive, for any positive integer n, there exists a positive integer n. Okay, so what we do at this point is you want to build up a contradiction. So what we do is we defined the set S. Now, if you have this, then b minus na is always positive. Define b, I meant to say S, to be the set of all b minus na's such that n is an integer that's positive. But we know that this is always positive. So, by the well-ordering principle, S contains a smallest element. Call it b minus ma. Now, b minus m plus 1a, well, this is b minus a positive integer times a. This is an S. So, but what is b minus m plus 1a? Well, it's b minus distributing ma minus a. But since a is positive, this is less than b minus ma. And this is an S. Wait a minute. I thought this was the smallest element. So, we found an element in S that is smaller than b minus ma. That's a contradiction. Okay, the only thing that we supposed that could be wrong is that na is less than b for every positive integer n. Okay, na is less than b for every positive integer. Well, that's not true. Therefore, NA is not less than B. That is, NA is greater than B for some N. For some positive integer N. And that's just what we wanted to prove. We wanted to prove, given A and B, then there is a positive integer N such that this is true. And that's just what I did. I showed that's true for some positive integer N. If you like mathematics like this, where we do proofs in this YouTube channel, then please subscribe. Leave a comment, positive or negative. I like looking at negative comments. Another thing is, if there's a video or a theorem, that you would like for me to prove, leave it in the comment section, and if I know how to prove it, I'll get to it. Most of all, watch and learn.